Video, we're going to have a look at some basic financial functions. The first one we're going to look at is future value. Okay, future value just basically tells me what my investment will be worth over a period of time with a given rate of interest. Okay, so bear with me while I share my screen. Okay, so I've just got some monthly savings here. Okay, so I'm going to save £200 a month at an annual interest rate of 15%, and I'm going to save for 60 months. Okay, so how much is that £200 going to be worth to me after that period of time with that interest rate? I've put the 200 into red, okay, just to make sure that it's a negative so that we know that it's money that's outgoing and not coming in. Okay, so we click into B7 for the future value. So you can either go into formulas and pick up the insert function from the first icon on the left, okay, or remember I tend to use the FX to insert my function from here. Okay, so these are in financial functions, so you'll get them, select the category financial, and you would just search for, okay, FV for future value. You can type in future value, but it'll come up as FV. And here we have it here. Okay, anything that's in bold, okay, in these dialog boxes mean that they are required fields. Okay, so the rate, okay, the rate is going to be the interest rate, and I'm clicked into the wrong cell, I beg your pardon, wait till I come out of here. I want to be in future value, I want to be in B7, I beg your pardon. Let's try that again. Pick up my FV from my most recently used this time, I didn't have to search for it. Okay, so the rate of interest is B5. Okay, remember, divided by 12, okay, because they're 12 months of the year. The N per is the total number of payment periods in the investment, okay, so the number of months basically that we're saving, okay, so that's going to be B6. And the payment, okay, again, it tells you down here, the payment made each period, okay, so the amount that we are going to pay is in B4. Click on OK. And we can see there that if we save £200 a month for 60 months, okay, at 15%, it's going to be worth £17,714.90. Okay, so that's future value. The next one we're going to have a look at is a payment function. Okay, so a payment function calculates the amount that will actually be repaid, okay, each month. So on a given loan amount. So we've got a loan here of £250,000, an annual interest rate of 10%, and we're going to make 120 monthly payments. Obviously, you could put that into currency to make it, okay, a little bit better, and let's just take the decimals off. Okay, so let's work out the monthly payments then. Okay, so again, I use my FX to insert a function. Again, you would go to financial and search for PMT, okay, the payment function. Try that again, PMT, and click on go, and here we have it here. Okay, so tells me here, calculates the payment for a loan based on a constant payments and a constant interest rate. So that's what we're looking for. Click OK. So the rate, as we know, is going to be B5, again, divided by 12. Okay, N per, or the number of payments for the loan, okay, is going to be B6. And the PV, okay, the present value is the amount in B4. Okay, so again, we can click on OK. Okay, and we can see there that the monthly payments are going to be £3,000 and £303.77, okay, over that period of time. I formatted this again to be a negative number in red, just to highlight that it is a payment going out. So remember, you just do that within the formatting for numbers, okay. You can get your negatives from here. Okay, so next one, straight line depreciation. Okay, so another nice, easy little calculation. Okay, so we've got Gwen's garage and we've got two lorries. One's worth 28,000, one's worth 15. Expected life years of 6, and annual depreciation is what we're going to work out. Okay, so straight line depreciation is one of the most simplest form of depreciation, okay, where we have perhaps an expected scrap value of 0 at the end. Okay, so we're just going to click into D6, click on FX. Again, you would go into your financial you type in SLN and go, and there we have it there. So again, returns the straight line depreciation of an asset for one period. Okay, so nice and easy. The cost of lorry 1 was £28,000, so that's B6. The salvage value we're saying is 0, okay? And the life expectancy of this particular lorry is 6 years, and we get that from C6. Just click on OK, and you can see there that we can drag it down into the next row, relative cell addressing, and we can see there that a lorry valued at £28,000 with 0 scrap value and the life expectancy of 6 years is 4,666.67. So I know you're all saying, why didn't we just say equals 28,000 divided by 6, because we're going to get exactly the same answer. Okay, so the difference is, what if the salvage value wasn't 0? Okay, so that's where the SLN, the straight line depreciation, comes into play for us. If there is an expected or anticipated scrap value at the end, okay, then that's why we need to use that particular calculation. Okay, I hope that's clear. Thank you for sharing.